This is Sharma solution, class 12, chapter 6, Determinants, VSAQ, very short answer questions. If A is a singular matrix, then write the value of determinant of A. So A is a singular matrix that means that the determinant is a 0. The value of the determinant of the matrix will be 0 if A is a singular matrix. So the answer is straightforward. The determinant of A is 0. For what value of x the following matrix is singular? So as we just saw, that singular matrix means determinant is 0. So how to find the determinant? This is 2 by 2 matrix. So we take this 5 minus x multiplied by 4 minus 2 into x plus 1. That is 5 minus x into 4 minus twice of x plus 1. So this is equal to 0. So this is singular. So you get 5 4 20 minus 4x minus 2x minus 2 equals 0. So you get minus 6x, 20 minus 2 is 18, plus 18 equals 0. So 6x equals 18 basically. So minus minus gets cancelled, x is 3. So the answer is x equals 3. So this is how you are going to write. Write the value of the determinant. Now this determinant, what is the value? The property, one of the property we are going to use. For example, these are 3 rows. Row 1, row 2, row 3. Now you see row 1 and row 2. If in the second row, if you take x common, what do you get? 2, 3, 4 in the second row. So the first row and second row become exactly equal. That means when we have x outside, we take x outside, then it will be 2, 3, 4, 2, 3, 4, 5, 6, 8. That means first and second rows are exactly similar. And we know when the 2 rows and 2 columns are similar, the determinant will be 0. So this taking out x, so this is going to be 0. State whether the matrix, this is singular or non-singular. So 2 multiplied by 4 minus 3 multiplied by 6. So we have 4 to the 8 minus 18 equals negative 10. So this negative 10 is a value that is not 0. Singular means it has to be 0. The determinant has to be 0. So the given matrix is a non-singular matrix. Find the value of the determinant. Now the straightforward method will be 4200 multiplied by 4203 minus 4205 into 4201. But doing this will take a lot of time because this is a very short answer question. That means we have to apply certain property to make the value or the computation easier. How to do this? And this kind of questions are coming number of times in the later discussion. So this is column 1, column 2. What we can do is we can either do C1 minus C2 or we can do C2 minus C1. So we have 4200 minus 4201. That is column 2 minus column 1. I don't want to do column 1 minus column 2 because that will be negative value. Same thing will come, but it will be negative. So column 2 will change to column 2 minus column 1. So 4201 minus 4200 is 1. 4203 minus 4202 is 1. Now you can apply the 4200 into 1 minus 4202. That is going to be negative 2. Find the value of the determinant. Now same thing what we have just discussed. The straightforward way is to open it using any of the row or column. But here we will follow the same strategy and the logic which we just saw. That is, we will first make this easier. And the result will be, for this particular example, the result will be quite easier. So column 2 will change to column 2 minus column 1. Column 3 will change to column 3 minus column 1. So column 2 will change to column 2 minus column 1. Column 3 will change to column 3 minus column 1. So what do you get? 101, 104, 107 this will be. So 102 minus 101 is 1. 104 minus 104 is 1. 108 minus 107 is 1. Now C3 will change to C3 minus C1. 103 minus 102 is 1. Or you can do C3 minus C1 rather than doing C2. So this will be 2. 109 minus 107 is 2. Now in the third column we will take 2 common. So when you take 2 common, let me just show it here also rather than writing whole of the determinant. So this will become 1 when we taken 1 common. So column 2 and column 3 are exactly similar. And when we know when 2 columns and 2 rows are similar, that means the determinants has to be 0. That is how in this question the determinant is 0. Write the value of the determinant. So we'll apply the property here. The question which we have already done, we generally do the row 1 plus row 2 plus row 3 or column 1 plus column 2 plus column 3. So if we do column 1 plus column 2 plus column 3, we will get A plus B plus C plus 1. In all of the first column, we will get A plus B plus C plus 1. Now we can take A plus B plus C plus 1 outside. You will get 1 1 1 1 1 1. It is the column 1 and column 2, that will be 0. So this is the one way. So rather than adding 1 means this all the 3 columns. If we add column 1 and column 3, that also will solve our purpose. Same thing. So we'll add column 1 and column 3 also. We're just adding column 1 and column 3. So it will be A plus B plus C. A plus B plus C, that is the first and then third one is C plus A plus B. A plus B plus C it will be. Now we have 1 1 1. Here we have B plus C, C plus A and A plus B. Okay, now we can take A plus B plus C common from the first column. So when we take this A plus B plus C, this taking common, you will get 1 here, 1 here and 1 here. So this 3 column, in this 3 column, 2 columns are same. So when column 2 and column 1 and column 2 are same, that means the determinant will be 0. 2 rows, 2 column equal, the determinant is going to be 0. Okay. As I said, you can also add C1, C2, C3, but more sophistication is the C different 2 columns. Now A is this, B is this. Find the value of determinant A plus determinant B. So 0 into 1 minus I into I square. Here 0 into 0 minus 1 into 1. So here you get 0 minus I square is minus 1. I squared is negative 1. So I'll write negative 1 here. Minus is going to be plus. So plus 1 here. Okay. Now here you get 0 minus 1, that is going to be negative 1. Negative 1. Okay. So 1 and negative 1. So we are going to add them. 1 and negative 1, when we add it is going to be 0. Now this is A, this is B. Now if you see the question properly, A determinant, B determinant and AB determinant. These are 3 things which we have to do it. Right. So what we'll do, we will multiply A into B. Then we will take the determinant. That is 1, 3, 2 minus 1 I am taking. This is A. And now I am taking this as B. 1 minus 1, 0, 0. So first we will multiply it. This row with this column. So what we'll get here? Let me just take this one. So 1 into 1 plus 2 into minus 1. So you get 2 into minus 1. So you can just take it as negative also, 2 into 1. Okay, first row and second column. So 1 into 0, 2 into 0, that is going to be 0 only. Now second row and first column. 3 multiplied by 1, 3 multiplied by 1 and minus 1 into minus 1. So it will be plus 1 into 1, 1 it will be. Now the second row will be second column. So 3 into 0 is 0, minus 1 into 0 is 0, 0 you get. So 1 minus 2 this will be, it is negative 1. 3 plus 1 is 4, 0, 0 you will get. Okay, now when we have a whole row or a column as 0, the determinant will be 0. You don't have to do anything, just this is a property. If any of the row or the column is 0, the determinant is 0. So minus 1 into 0 minus 4 into 0. So this is 0, this is 0, you're going to get the answer as 0. Okay. Now we'll apply the same thing here. First you can directly do it, but multiplying 4 numbers with 4 numbers will take some time. So the best way is to make it easier. So we'll change the column 2 with column 2 minus column 1. The first column we are writing like that only, 4, 7, 8, 5 and 4, 7, 8, 9. Now we'll do column 2 minus column 1. So 4, 7, 8, 7 minus 4, 7, 8, 5. Column 2 we are changing to column 2 minus column 1. 4787 minus 4785, that is going to be 0. 4791 minus 4789 is going to be 2 only. So now we take 2 common. So when we take 2 common, you get 1 inside. Now you can directly do 4785 into 1 minus 4789 into 1, and that is going to be this 4785 minus 4789. It is going to be negative 4. 2 into negative 4 is negative 8. This is your answer. Minus 8 will be the answer. But this is all the steps you have to follow. Okay, I'm just giving you a logic how to do this. But in exam you have to follow all this procedure. This is omega. This is not W. If omega is an imaginary cube root of unity, find the value of. So what we can do here is, we can either, there are certain property, that is 1 plus omega square is equal to 0 and omega cube is equal to 1. We don't have to use the second property, but 1 plus omega square equals 0. So what we'll do, column 1 plus column 2 plus column 3 will do, or row 1 plus row 2 plus row 3, whichever you want. So row 1 we are changing to row 1 plus row 2 plus row 3. Okay. So let us add the rows here. Row 1, row 2, row 3. There can be different ways, column adding and row adding. So I'm adding row. The solution I've showed you is using the column adding. So I'm adding the row 1 plus omega square. This second row will also be added, 1 plus omega square. 1 plus omega square, third row. What we will get, omega square 1, omega square 1 omega, and then the 1 plus omega square is 0. So if you take this outside, rather than taking it, it's same thing, because the 1 plus omega square is 0. So we have whole of the row, one row, first row is 0. And as I said we discussed earlier, if the whole row is 0 or whole column is 0, that means the determinant is going to be 0. Now A is this and B is this. Now here I was talking about, because this type of question we have, I think 9 question was there. So what we'll do here is, the question is saying, if A and B are square matrices of the same order, then if AB determinant, A multiplied by D determinant is equal to determinant of A multiplied by determinant of B. That is, so A, B determinant. So what we'll do here is, we'll try to find out the determinant of A, we'll find out the determinant of B, we multiply them, and that is the determinant of A and B multiply. Right? Okay. So here we'll do the A determinant, that is 1 minus 1, 1 into minus 1 into 2 into 3. Then B is 1 into minus 2, minus 4 into minus 3 into minus 4. So it is minus 2 plus 12 is 10. Now minus 7 and 10 has come as the determinant of A and determinant of B respectively. So we will do what? We will multiply these two. That is, determinant of AB is determinant of A and determinant of B. And that is going to be minus 7 into minus 10, minus 7 into 10. And that is going to be negative 70. Okay. Now 13th question is, if A equals Aij is a 3 by 3 diagonal matrix such that A11 equals 1, A22 equals 2 and A33 equals 3, then find the determinant of A. So diagonal matrix, that means the values will only be in the diagonal, other values will be 0. And since the diagonal matrix 3 by 3, the values are given, that is A11, A22, A33 is given. So one is the A11 is 1, A22 is 2, A33 is 3. 0, 0, 3 it is. Okay. Now when this in the diagonal matrix, we have to find out the determinant. So there are two ways you can do. Either you open using any row or any column, 2 zeros will be there because this is a diagonal matrix. But the best way is, the property says that you just have to multiply the value of the different diagonal elements. That is 1 into 2 into 3. Because 1 and 2, 3 are the diagonal elements. You get 6 as the value. If A equals Aij is a 3 by 3 scalar matrix such that A11 equals 2, then write the value of determinant of A. So scalar matrix is just a diagonal identity matrix multiplied by the scalar value, and that scalar value will be in position of 1, which was if the diagonal matrix is unit matrix, 1 will be there. So that scalar will take the place of the places of 1. So this is 1 0 0 0 1 0 0 0 1. So if this is 2, a11 is 2, that means the scalar value which is being multiplied to the identity matrix is actually 2. So as we just seen in the previous question, it will be the multiplication of diagonal element 2 into 2 into 2, that is going to be 8. Right? I hope you got the idea. Or you can do what? You can open it using any row or column. That you can do. Just use any row or column and just open it. It is going to become, the value will come as 8. Because examiner would love if you write like this and open this rather than writing that because you have to write this property if you are doing it using just multiplication of the diagonal element, and that is the property we have already seen while we were discussing the theory. Okay. If I3 denotes identity matrix of order 3 by 3, write the value of its determinant. So I3 is the 3 by 3 identity matrix, that is the A11, A22, A33, or you can say Aij, where I equals to j. All these values will be 1. So when you want to find out the determinant, it's simply multiplying the values of the diagonal values. So this is I3, that is 1 0 0 0 1 0 0 0 1. So Aij, that is I equals j, all this value will be 1, and the final determinant will be 1 into 1 into 1, that is going to be 1. Right? So, or you can open it using any row and column. Essentially this 1 is going to come. Either way you do it. Use the property, because if I multiply this, if I just open it using, say, first row, second, third value will not be there. First row 1 into 1 minus 0 into 0, that is going to be 1 only. A matrix A of order 3 by 3 has a determinant 5. What is the value of 3A? Thrice of A, then the determinant of that value. Now, this is a very straightforward question with a simple explanation. The explanation is that if you have this 3, let us call it as K, some K. Now, when we try to find out the determinant of this K, when you take it outside, you are taking it outside from either 3 rows or 3 columns. So it is K to the power N. N is the number of rows and column. Okay. K is a constant. N is the order. So it is K to the power N. So here we have 3 as K. Order is also 3. So 3 by 3. 3 raised to the power 3. And the determinant of A. And since the determinant is already given as 5, so you just have to multiply this 5 with the 3 to the power 3. Okay, if the order would have been 4 by 4, it would have been 3 raised to the power 4. Order 5 by 5, it is 3 by 5 in this case. So how do we do this? First, we will take the order. This is K. We are taking K outside, raising it to the order, power of order, 3 to the power 3, and the determinant. Determinant has the value 5. So 3 raised 3 is 3 into 3 into 3. 3 is the 9, 9 3 is the 27. So 27 into 5. This is going to be 135 because it is 27 into 5, and that is 135. Or expanding by first row, the value of the determinant of 3 by 3 square matrix. This A is given as Aij. This is A11, C11, A12, C12, A13, C13. Now A11, A12, A13 can be either a column or a row. But the second part, that is C, is the cofactor. If it is A11, it will be C11. A12, it will be C12. That is the cofactor corresponding to that certain value. Write the expression for its value on expanding by second column. This question is saying about first row, asking about the second column. So there are 3 rows, 3 columns which I am making now. So A11, A12, A13. This is how the values are represented. Aij, I is for row number and J is for the column number. So A21, A22, A23, A31, A32, A33. 3 rows, 3 columns. Okay. Now, when we want to expand it using the second column, where is the second column? Let me just change the color. This is what we are calling as the second column. A12, A22, and A32. And what are the values we are going to put here?
the cofactor and the subscript will remain same. A12, C12, A22, C22, A32, C32. This is your answer. Now, this is how you are going to do it. These are the whole steps which you have to follow. But I have given you the logic, what it actually means. So let me just clear it and you can have a look here. Let Aij be a square matrix of order 3 by 3 and Cij denote cofactor of Aij in A. If determinant of A is equal to 5, write the value of A31 C31 plus A32 C32 plus A33 C33. Okay. Now the simple explanation is, whichever way you take the determinant is going to be the same value. Any row you take to open the determinant, any column you take to open the determinant, the value of the determinant will not change. Since the determinant is already given as 5, you take any ways, either ways, the determinant will remain same, is going to be 5 always, right? So now this is A13, A1, the question is asking about A13, C13, A23, C23, A33, C33. So basically you are opening it using the third row, but determinant won't change. In question 18, write the value of A11, C21, A12, C22, A13, C23. Remember, we talked about A11, C11, A12, C12, A13, C13. But here, the cofactor is not corresponding to the value. So we already know that if we are talking about a square matrix of say order n, the sum of the products of element of a row or a column with the cofactors of the corresponding elements of some other row or column is 0. That is, we are taking the value, but we are not taking the cofactor of that value. We are taking the cofactor of some other row or a column. Then the value will be 0. You remember, we just talked about A11, the C should be C11. The cofactor has to be the same. Cofactor should be corresponding to that particular value, but it is not in the case. Since the elements of the first row here in this example and are of the first row, A11, A12, A13 are the elements of the first row, and the cofactors are the elements of actually the second row, which is C21, C22 and C23. And we know already with the properties when we discussed that if we multiply this kind of way, then the corresponding value of the determinant is going to be 0. I hope you got the idea. If I take A11 into C12, A21 into C22, A31 into C32, it's also going to come as 0. So either ways, you take any column value with corresponding some other column or say row cofactor is going to be 0. This is a rule. You need to know it. Write the value of this. So you just have to do it. Means just cross multiply and subtract. Sin 20 multiplied by cos 70 minus cos 20 sin 70. Since it is negative becomes plus. So sin A cos B plus cos A sin B, that will be the answer. But here we have a trigonometric identity. This is sin A cos B. If I take 20 as A and 70 as B, sin A cos B plus cos A sin B will be sin A plus B. So sin 20 plus 70 is sin 90, and sin 90 is what? Is equal to 1. If A is a square matrix satisfying A transpose A equals identity matrix, write the value of this determinant of A. Please remember, if a matrix, the determinant you find out, and you take the transpose of that matrix and take the determinant, they won't change. They won't change. So I'll show you step by step how we are going to get this value. A is a matrix. It is square matrix. The order is n by n. When we take the determinant of matrix, if you take the determinant of A or determinant of A transpose, transpose is simply changing row to column, and it is going to be same. It won't change. First thing, okay. Now A transpose A is given as identity matrix. Let us take the determinant both sides. When we are taking the determinant of what? The identity matrix. For example, 2 by 2 identity matrix. So I told you that when we have identity or scalar matrix or diagonal matrix, just multiply the diagonal values. That will be the determinant of that matrix. So it will be 1. Determinant of I is 1. Now since A transpose is 3 by 3, A is also 3 by 3. Okay. Determinants are of the same order. And we know that A into B or determinant can be written as A and B separately determinant and multiply. That is A, B determinant will be A determinant, B determinant. So how are we going to write? A transpose and A equals 1. Okay. That is the determinant of A is 1 over A raised 3. But we know that transpose and the actual determinant, the determinant remains same as I just said. So you can write it as again A transpose is A. Now you just multiply across. The determinant of A square is equals 1. Determinant of A will be plus minus under root 1. Under root 1 is 1, so plus minus 1 it will be. Right? Plus minus 1. If A and B are square matrices of the same order, such that the determinant of A is 3 and AB equals I, then write the value of determinant B. Okay. So we'll apply the same property. Since if the square matrices are of the same order, then there is a property of determinant. That is AB multiply, then take the determinant will be A determinant separately with B determinant. And since determinant of A is already given as 3, and this A and B, if you multiply, it is I. So just write I here. And we have already seen just now that the determinant of identity is 1. So it is 1 equals 3 B and B 1. You can take 3 on the left hand side. It is 1 by 3. A is a skew matrix. A matrix of order 3, write the value of determinant A. And there is a concept, there is a property. We just have to understand this one. That skew symmetric is when you take the transpose of any matrix, it should come as negative of that matrix. A transpose minus A. So if the order is even, that is the n by n order, n is even or order is odd. If order is even, there will be some value. But if the order is odd, the determinant will be 0. Right? Now, what is the order of this particular, in this particular case? The order is 3. Is it even or odd? It is odd. So, when it is odd, that means the determinant of skew symmetric will be 0. Determinant A is 0 because the skew matrix, it is skew symmetric. And of course, the 3 is odd. If A is a square matrix of order 3 with determinant 4, then write the value of minus is there outside. You can take a minus outside. How? We just saw in this previous question that if we have a determinant with a scalar multiplied inside, minus means what? You can write it as minus 1 into A, same thing, inside the determinant. Now this minus, assume it to be K. So when you take Ka, when you try to find out determinant, it will be K raised n when it comes outside of the determinant. And then determinant of A remain inside. So K raised n, K is minus 1 to the power n. And inside you have determinant of A. So minus 1 to the power 3, determinant is 4. So it is minus 1 into minus 1 into minus 1. It is going to be minus 1 only and minus 4 it will be. if A is a square matrix such that determinant of A is equal to 2, write the value of A into A transpose. A into A transpose. So in a square matrix, A transpose, the value won't change, determinant won't change. So A dot A transpose, because the orders are same, so you can just write it as A determinant and A transpose determinant. I told you AB determinant will be equal to A determinant multiplied by B determinant. The value of determinant of A is already given in the question. It's 2. So if you take the transpose or whichever, I told you the determinant won't change. So determinant of A and determinant of A transpose will be same. So it is 2. 2 into 2 is 4. The answer is 4. Find the value of the determinant. Now you can do it directly, but it will take time and answer will come same. That is why we need to learn the properties of the determinant. We'll apply the property here. The property is to make this determinant easier. And most of the time when we apply the property, most of the time the determinant comes to be 0. Because these are very small answer question. Then rather than doing all, try something so that the determinant computation becomes easy and it may come as 0. So this is row 1. We have row 2 and row 3. Now you see 81 into 3 is 243. 52 into 3 is 156. 100 into 300 is 100 into 3 is 300. So if you multiply the second row with 3 and subtract the first row and second row, you are going to get 0. 100 multiplied by 3 is what? 300. So let us multiply the second row with 3 and subtract it with the first row, and that is going to come as 0. Hope you got the idea? We subtract them. So R1 we are changing R1 minus 3 into R2, because 243 is 81 into 3. 156 is 50 into 3. 300 is 100 into 3. You can take 3 outside anyways. So 2 rows become same. So the logic is same. You can do it using the row properties, or you can just subtract these two, or you can say 2 rows are same. The determinant is 0. 2 columns are same. Determinant is 0. So this 0, 0, 0. This says the whole row is 0 and the determinant is going to be 0. Write the value of the determinant. Okay. Now you see, as I said, there are multiple ways to do it. 2, 4, 6. 2 is 2 into 1, 4 is 2 into 2, 6 is 2 into 3. So I am just taking 2 outside. What it will be? 1, 2, 3 inside. Minus 3, minus 6, minus 9. Minus 3, can I take minus 3 outside? Yes, minus 3 I can take outside. What will be remaining? Minus 3, minus 6 will be 2 and minus 9 will be 3. 5, 10, 15. Can I take 5 outside? Yes, 1, 2, 3 will remain. So the 2 rows and 2 columns, if they are same, means 2 rows or 2 columns are same, the determinant will be 0. Here you see all the 3 columns are equal, that means 0, right? Now there are, as we saw in the previous question, we can apply the property also. What is the property? You can do R2 minus 2R1. R2, because 4 is 2 into 2. That is how you can do it. If the matrix this is singular, find the value of x. Singular is cross multiply 5x multiplied by 1 minus 2 multiplied by minus 10. So it will be plus 20. 5x plus 20 equals 0. X will be equal to minus 20 by 5. So minus 4 it will be. X is minus 4. Right? If A is a square matrix of order n by n such that determinant of A is equal to lambda, then write the value of minus A determinant actually. Now we just saw a question, and what it will be? Minus A means minus 1, it is minus 1 into A. When we take it outside, it will be to the power of n. That is the order. Determinant will remain inside. Determinant of A is lambda, minus 1 to the power n lambda. This is the answer. Find the value of the determinant. Now either you open it and solve it. That will take a lot of time. Let us apply the property. The property is just take the scalar outside. Let us take certain thing common factors. So from you can take it from rows or column, either way. It's up to you. So we are taking 2 square from the first row. It will be 1 here, 2 here, and 2 square here. You can take from second row, you can take 2 cube common. It will be 1, here 2 square. Let us take 2 to the power 4 common from third row. 1 to 2 square will be there. Now you see all the 3 rows are same. When the 3 rows are same, that means it is 0. Or you can say 2 I can take from second column and 2 square from third column. All will be 1, 1, 1, 1, 1, 1. It will be 0. If A and B are non-singular matrices of the same order, write whether A into B, that is singular or non-singular. So let me tell you first that what is singular and a non-singular. Singular matrix means the determinant, if you take the determinant of any matrix and that comes to 0, that means it is singular. Non-singular means the determinant A will not be equal to 0. And for B also the same logic goes. B equals 0, that is determinant 0, singular, non-zero, non-singular. So A, B, if you multiply those and take the determinant, and if the orders are same, then it will be equal to A and B, determinant separately, and then multiplication. Now we have to write whether A, B is singular or non-singular. So for that, this AB is multiplied and then determinant is singular if it is 0, non-singular if it is not equal to 0. Since we have already discussed that it is these A and B are non-singular, that is neither A determinant is 0 nor B determinant is 0. So when they both are not 0, AB determinant cannot be 0. So that is AB is a non-zero and AB is non-singular matrix. A matrix of order 3 by 3 has determinant 2. What is the value of A 3I, where I is the identity matrix of order 3 cross 3? Now what all is given? Let us write this first. Matrix is there and the order is given 3 by 3, that is it is a square matrix of 3 by 3. Now the determinant of this A matrix is 2. The order is n, 3. Now identity matrix, it is 3 by 3, so you have 1, 1, 1 in the diagonal, you multiply them and you'll get identity always as 1. If you take the determinant also, it will be always 1. So I is the identity matrix. Now what is 3 into I? 3 multiplied by identity matrix, that is 3 into I, which is actually equal to 1, and you get 3 only. So 3 into identity will be 3. So you got this value as 3. Now you have to multiply this with A, that is 3 is there. So you can write A dot 3 as 3 dot A. This is 3 dot A. Okay. Now as I told you that if you take K into A, K can be taken out, K raised n and determinant of A. This is true. N is what here? This n is 3 and K is also 3. So it will be 3 raised 3 determinant of A. 3 to the power 3 is 27. Determinant of A is already given in the question, which is 2. So 27 into 2 is 54. The answer is 54. If A and B are square matrices of order 3 such that they are square matrices, the row or columns are same, and this is order 3, that is 3 by 3 matrix, and it is given the determinant of A is -1, determinant of B is 3. So 3AB, what this will be? See, first AB, let us assume that A multiplied by B is something, say X. So when you multiply this K with X and then you take the determinant, if K is scalar, you can take it out and it will be raised to the power n, and then you have inside X, that is actually AB. So K raised n, what is K here? It's 3. What is n? The order is 3. So this is 3 raised 3. 3 raised to the power 3. So it is 27. And now the determinant of A and B. Now since the order of these square matrices are same, so AB determinant will be equal to determinant of A and determinant of B is separately. Determinant of A is -1, determinant of B is 3. So -1 into 3. And you already have a K raised n, which is 27, we already calculated. So 27 multiplied by -1 multiplied by 3, and that is going to be minus 81. Now write the value of this. So it's simply 2 by 2 matrix, so just cross multiply and subtract. So let me just tell you, because when we talk about the complex theory or complex mathematics, this I is special because I square is equal to negative 1. So I square is negative 1, so when we will multiply, you will get I square. So you just have to replace this I square with negative 1. So let us multiply this. A plus IB into A minus IB. A plus IB into A minus IB. Now you need to subtract this. C plus ID. And since it is minus C plus ID, if you take negative outside of minus C plus ID, it can be written as C minus ID, and negative can be taken out. Minus minus will be plus. Okay. You can apply this A square minus B square, A square minus I square B square. And then plus this C square plus I square D square. Or C square minus I square D square. So I square is minus 1. So it will be A square plus B square plus C square. Here also I square is minus 1. Minus minus become plus. So you get A square, B square, C square, D square all added. What is the cofactor of A12 in the following matrix? Now remember, A12 is what? There are 3 rows and there are 3 columns. So A12 means first row and second column you have to find. Because if you write Aij, I correspond to the row number, J corresponds to the column number. So first row, second column. Okay, this is minus 3. The minus 3, the cofactor, first let us find out the minor. And then we'll assign the sign. So it will be 6, 1 and 4 minus 7. 6, 1, 4 minus 7. Now cross multiply, find out the value. 6 into minus 7 is 7 6 are 42, negative 42, and minus 4. So this is minus 46. So this is your minor. Now in order to find out the cofactor, you have to multiply it with the minus 1 to the power I plus j. What is I? What is j? I is 1, j is 2. So I plus j is 3. Minus 1 to the power 3 is minus 1. So you have to multiply this minor with negative 1. As I said, minus 1 to the power I plus j are 1 plus 2. And minus 1 to the power 3, because 3 is odd, it is going to be negative 1. Multiply, you get 46. Please remember, cofactor is minor with the sign. Now this is equal to 0. So just cross multiply and subtract. So 2x plus 5 into 9 minus 3 into 5x plus 2 equals 0, 0. So let us just write it to 9 into 2x plus 5, because this kind of question is following. There are various questions like this. Minus 3 into 5x plus 2 equals 0. So 18x plus 5 is a 45 minus 5 is a 15x minus 6 equals 0. 18x minus 15x is 3x. 45 minus 45 minus 6 is 39. X equals minus 39 by 3. And this is going to be negative 13. Find the value of x for the following. Simply x into 2x, 2x square minus 4 to 8. So 2x square minus 8 equals 0. You get 2x square equals 8. So divide both sides by 2. You get x square equals 4. And that is x equals to plus minus 2. So plus minus underscore 4 is plus minus 2. So this is the answer, plus minus 2. Both you are going to take. Write the value of the determinant. Now you see here, we have this third row. So you can take x common first. And after you take x common, you take 6, 9 and 12. What is 6? 2 into 3. What is 9? 3 into 3. 2 into 3. 3 into 3. And 12 is 4 into 3. So you can take 3 common from here. When you take 3 common from here, it will be 2, 3, 4 remaining. So when you take x common, since 3 and x common, from the third row, 2, 3, 4, 5, 6, 8 and 2, 3, 4 will remain. First row and the third row, they are exactly similar. And when 2 rows and 2 columns are similar, that means the determinant is going to 0. So all will be 0. Since here I've just given 2x, so let me change it here. One more thing you can do, you can directly take 3x common at once. I just gave you idea why we took this 3x out. There is a reason. So what do we get? Is equal to 0. R1 and R3 are identical, and when two rows and columns are identical, the determinant is going to be 0. If determinant of A is equal to 2, where A is 2 by 2 matrix, find adjoint A. Now the adjoint and the inverse and all these questions we'll take in the next discussion, right? But the direct answer, because I'm going to tell you this here, there is one more question coming up. So this adjoint A, determinant of adjoint A is simply, what is that? A determinant raised to the power n minus 1. So determinant of A is already given as 2. What is n? 2 here, 2 minus 1. So 2 raised 2 minus 1, 2 raised 1 is 2. What is the value of the determinant? So you just see that there are 2 zeros in the first row. So the best way is to open it. Okay, when you open it, it will be only 2. So you'll get the minor as 2, 4, 4, 6. And it will be simply 6 to the 12 minus 4 for the 16. So simply, rather than going all the way to find out properties, etc., the numbers are easy. That is, the calculation will be quite easy. So this first row I am opening. I am not taking the first and the third value because it is going to be 0. It will be minus 2, 2, 4, 4, 6. As I said, it will be 12 minus 16. That is going to be minus 4. So minus 2 into minus 4 is going to be 8. For what value of x is the matrix this singular? So in order to get this matrix as singular, we have to cross multiply and put it equals to 0. That is 6 minus x into 1 minus 4 into 3 minus x is equal to 0. 6 minus x minus 12 plus 4x equals 0. 4x minus x is 3x. 6 minus 12 is minus 6 equals 0. So x becomes 2. So the determinant of being singular, the x is 2. A matrix A of order 3 by 3 is such that the determinant of A is 4. Find the value of determinant 2A. So this is k raise n. Simple thing is, the final value will be k raise n determinant of A. What is k? 2. What is n? 3 into 4. Determinant of A is already given. So 8 4s are 32 it will be. This is 32. So this you can directly use, do it, and you will have to use the identity, trigonometric identity. So cross multiply cos 15 cos 75 minus sin 75 sin 15. So cos A cos B minus sin A sin B. You get cos A plus B. So what is A here? 15B is 75. So A plus B is 75 plus 15 is 90. So cos 90 it will be. And cos 90 is simply 0. So the answer is 0 here. Write the cofactor of the element A32. What is the third row? This one. What is the second column? So you are getting the value as 2. A32. So just leave the intersection of the row and column here. 5, 2, 8, 1 will be the minor. And what will be the cofactor? Minus 1 to the power 3 plus 2. So this is odd power. 5 minus 8 to the 16. It will be minus 11, and there is already minus here because minus 1 to the power 3 plus 2 is minus. So it will be 11. Minor is cofactor without sign. Cofactor is minor with sign, right? So negative we multiplied just because minus 1 to the power 3 plus 2. So this kind of question, just cross multiply. This is 2 by 2, and let me show you what will happen. X plus 1 into x plus 2, x plus 1 into x plus 2 minus x minus 3 into x minus 1. So x plus 1 into x plus 2 minus x minus 3 into x minus 1, and this is equal to 4 is a 12, minus minus plus is plus 1, so it is 13. So when you solve it, it will come as, because x square is going to get cancelled, 3x plus 4x will be 7x, and 2 minus 3 is minus 1, x will be equal to 2. Same here, same question. So 2x into x plus 1 minus 2 into x plus 1 into x plus 3 equals 3 into 1. 3 into 1 minus 5 is a 15. So simply x equal to 1. This is a very, just like previous question, it's quite easy. Similarly here, 3x into 4, that is 12x minus or minus plus, so 7 is a 14, and this equals 8 for the 32, minus 7 6 is 42. So you get minus 10 here. So x will be equal to minus 2, negative 2. Same here, 2x into x minus 5 into 8, so 2x square, 5 is a 40, and this is 6 is a 18, and 7 into minus 2 is 14, plus 14 will be, x is plus minus 6. Now if A is 3 by 3 matrix and the determinant of A is not equal to 0, and the determinant of 3A is equal to k into the determinant of A. Now 3A, so I told you when you take this 3A, this is k, so it's, let us assume it to be p because k is already given in the question. Let us take some other letter. It will be p to the power n, that is k to the power n, I told you earlier, p to the power n a. What is this? 3 to the power 3a. 3 to the power is 27, and this is a. So this determinant of 3a is 27 and determinant of a. Okay, so you can do it like this also. A, you can write it as a proper matrix with certain indicators, and then you can do this because when you have 3a, 3 will be multiplied to every element. When you take it out, it will be 3 by 3, 3 raised 3, and 27a will be there. So k is 27 here. What is the value of the determinant? It is p into p square minus p plus 1 and p minus 1 multiply p square minus 1, a square minus b square, that is p square minus p square plus 1. P square gets cancelled, you get 1. So the determinant is 1 here. Write the value of the determinant, this one. So there are multiple ways to do it. First of all, you have negative 3 in the third row. You can take negative 3 outside. X plus y, you can add row 1 and row 2 to get x plus y plus z. Because x plus y plus z will be in the first row, all the values, x plus y plus z, x plus y plus z, x plus y plus z. And you can take this x plus y plus z common, and you get 1, 1, 1. And since you will also take minus 3 from the denominator, that will also come as 1, 1, 1, 1. So you'll have 1, 1, 1, 1, 1, 1 in the first and third row. So I am adding first and second row, and then I am taking x plus y plus z common. So 1, 1, 1 will remain. We have zxy, and this negative 3 also we are taking outside, minus 3. So you have 1, 1, 1. And since the first row and the last row they are equal, that means the determinant will be 0. 2 rows, 2 columns equal, they are going to be 0. If A is cos theta sin theta minus sin theta cos theta, then for any natural number, find the value of determinant of A raised n, A raised to the power n. So see, A is given like this, but we have to first find out and generalize what will be A raised n. Okay, what will be A raised n? So let me just give you an idea. This A, I'll multiply A twice. That is, we'll try to find out A square. So we'll properly multiply it, and then we'll generalize it. A square is what? Cos theta sin theta. Here you have minus sin theta cos theta. Multiply it again. So we have this cos theta sin theta minus sin theta and cos theta. So cos theta sin the first row with the first column. Let me just show you here what I am doing. Cos theta sin theta and cos theta minus sin theta. First row and first column. So cos square theta, and then we have minus sin square theta here. We'll add them because since we have negative sign, I'm using negative sign. Then first row with the second column. What do you get? Cos sin theta sin theta, and plus sin theta cos theta. Then the same here, second row and first column. So minus sin theta cos theta minus sin theta cos theta. And then we have cos theta sin theta, it will be also minus sin theta cos theta. Then second row with the second column. So minus sin theta is minus sin square theta. And then cos theta is cos square theta. Okay, you got cos square theta minus sin square theta in two places. And cos theta plus sin theta also in two places if we take the negative from minus sin theta cos theta minus sin theta cos theta. So cos square theta minus sin square theta is cos 2 theta. So I am writing it here. And sin theta cos theta and sin theta cos theta is 2 sin theta cos theta. So twice of sin theta cos theta is nothing but sin 2 theta. Just write sin 2 theta here. Here also minus of sin 2 theta here. If you take minus common, you will get the same thing. Now when we took a square, this is 2 is coming here, here, here and here. So a raised n is, when we generalize, it will be cos n theta sin n theta minus sin n theta and cos n theta. Okay. Now, when we try to find out the determinant, let us see the determinant. Just cross multiply and subtract. So cos n theta into cos n theta will be cos square n theta, and minus sin n theta sin square n theta. But minus minus will become plus. So it will be sin square theta plus cos square theta. Actually, theta is n theta here. So it will be 1. So determinant will be 1. Find the maximum value of this. So either you operate using a row or using the column, the answer is going to come same. That is, if you apply the column, then it will be column 2 minus column 1 and column 3 minus column 1. And we can do it using the rows also. So row 1 will change, or row 2 will change to row 2 minus row 1, and row 3 will change as row 3 minus row 1. So 1 minus first row I am writing it, this one I am subtracting the second first row from second row. Similarly, the subtraction of R3 minus R2, R1 will give you 0, 0 and cos theta. Okay. Now just open it using the first column. So it will be 1 into something minus 0 and plus 0 into something. So it will be this one, sin theta 0, 0 cos theta. So it will be sin theta cos theta simply minus 0. So it will be sin theta cos theta. Now sin theta cos theta can be written as, when you multiply 2 and divide by 2. So 2 sin theta cos theta is sin 2 theta divided by 2. Now sin 2 theta by 2. Now we know that sin theta, the minimum and maximum value of sin theta or cos theta is negative 1 and plus 1. The range is like this. They both are inclusive. So when we divide by 2, just divide by 2 in both sides. So the maximum value is right hand side half. Maximum value is half. Now x belongs to n. Now same thing you have to do, x plus 3 into 2x minus 3x into 2. So you will get some value, and the value will be x square equals 4. X will be equal to plus minus 4. So plus minus under root 4 plus minus 2. But because this is natural number, you cannot take x equals to minus 2. So the only answer will be x equals 2. Now let us just solve it. The best way is to solve it. And since we have already done this type of question, so I am just doing it and open it using the first row, let's say. So x sin theta and cos theta, and take the cofactors of this x sin theta and cos theta. There are certain things which are going to come here. When you multiply, I hope you will be able to do the first part. When you resolve it, you will see it will be x cube plus 8. Because certain minus x and x will cancel, sin square theta plus cos square theta will be equal to 1. So x cube plus 8, what does it mean? We will use the formula of a cube plus b cube, x cube plus 2 cube. So a cube plus b cube is a plus b, a square plus b square minus ab. Now you see here, multiple of these two equals 0. So either x plus 2 is 0 or x square minus 2x plus 4 equals 0. But since x square minus 2x plus 4, you apply any value here, it will not be 0, or it will always be greater than 0 actually. I'll just show you with certain number. So only x plus 2 can be 0. So x will be equal to minus 2. What I'm trying to suggest here is x square minus 2x plus 4 cannot be that value 0. Okay. So when we apply, say I'm putting 5 value, x is 5, you will get some value which is greater than 0. So x plus 2 has to be 0. The other part will not be 0. So x will be equal to minus 2. If A is 3 by 3 invertible matrix, then what will be the value of K? Determinant of A inverse is equal to determinant of A raised to the K. And inverse and adjoint we are going to take in, because we have not discussed this. So we'll be taking in the next discussion, but I already told you one thing, but A inverse is adjoint of A divided by the determinant of A. So when you try to find out the determinant of determinant of A inverse, let us apply the determinant on right hand side also. And this adjoint A, determinant of adjoint A is what? I already told you that adjoint of A is nothing but, if you want to find out the determinant of this, it will be equal to the determinant of A raised n minus 1. So you can write it as determinant of A raised this minus, so you have n as 3 and 3 minus 1 is 2. So this is A square. This you can cancel one of it. So it will be determinant of A. So determinant of A inverse is determinant of A. So what is the power? Power is 1. So what is K? K is 1. If it would have been K, because it is K and K is equal to 1. So you can just write K equals 1. Okay, this is all about VSAQ. Thank you so much. Take care of yourself.